Hello student, now we are going to perform bridge rectifier circuit. Bridge rectifier circuit contain 4 diodes 1, 2, 3, 4 and you just follow. In these 4 diodes contain makes 4 junction, one here, another here, here and here. Here both the cathodes are connected. In opposite side you follow both anodes are connected and your resistance is connected across these two terminal. Other two junction, a cathode, a anode, here also a cathode, a anode is connected and here power supply, AC power supply is connected. Now we will construct our circuit. First of all, you choose two diodes, both cathode. So first you short the cathodes. In same line we are connecting both cathodes. Then other end, say we are connecting here, another we are connecting to any other points. So here both cathodes are shorted. Now you choose another two diode anodes. So we will short our anode to any other points, one anode, another anode. Now this cathode one will go here, another will go there. Now you minutely follow, there are 4 junction, one junction where both cathodes are there, another junction where both anodes are there. Here a cathode anode, here also a cathode anode. So our resistance will be connected between both cathode and both anode. So our resistance is connected here. So bridge is now complete and we will give power supply. So here 5 volt and 0 volt. So you can connect between cathode anode and cathode anode. Now our circuit is complete. You have to take all these readings. The first reading is input voltage, that is whatever input we have connected, that you have to measure with CRO. Then peak output voltage, that will be output voltage across the resistance. Then DC voltage measured with DMM multimeter. Then DC voltage you have to calculate. Then RMS, that is how much AC voltage is there, that you have to measure. Then ripple factor is a ratio between AC voltage and DC voltage, you have to calculate. Then we have to measure frequencies, input and output. Then we will connect a capacitor. Capacitor means a filter capacitor. Filter capacitor will be connected parallel to the resistance and it will filter the circuit. So again we will measure DC voltage and AC voltage. So after connecting the capacitive filter, our DC voltage should increase and AC voltage should decrease. Now first reading AC input voltage. So our CRO, your CRO is here. So we will connect our CRO to the AC voltage. And we will measure from CRO. You just follow. It is from here to here. It is 1, 2, 3, 4, 5, 6, 7. Peak to peak 7 division into 2 volt per division. So 14 volt total. And what about the peak voltage? That is the 7 volt. The first reading input is 7 volt. The second reading output voltage. Output will be across the resistance. So our CRO will be connected between resistance and you can follow in CRO. The reading is how much? It's 2.8 into 2 division, that means 5.6 volt. So output voltage or it is VM equal to 5.6 volt. Now third reading is DC voltage with multimeter. Now we have to use our multimeter to measure DC voltage. So multimeter probe will be connected between this resistance, here positive, here negative, and the reading is 3.38. Okay. So next reading is RMS value. RMS means how much AC is there. So we have to set our multimeter to AC level. Then between same terminal, that is across the resistance, we will find out how much AC, this and this, and your reading is 1.9 something, 1.9 volt. Next one is the calculation, ripple factor. Ripple factor is RMS by DC. So your RMS value 1.9 volt and DC value is 3.38. So calculation will be 0.56. Theoretical value of ripple factor is 0.48 and we are getting 0.56. Next reading is frequency, input frequency. So input frequency we can obtain from CRO. We will connect our input signal to the CRO and you just follow. It is 1, 2, 3, 4 division. 4 division into 5 milliseconds. So time period is 4 into 5, 20 milliseconds. The frequency will be reciprocal of that. That means 1000 by 20, it is 50 Hertz. So input frequency is 50 Hertz. So you can write down this. Then output frequency. So we can connect our CRO to the output and we will find out output frequency. And you just see the output frequency. It is 2 division. 2 division into 5 milliseconds. That is 10 millisecond is the time period. So then what is the frequency? Frequency will be 1000 by 10. That is 100 Hertz. Actually frequency is double here. Output frequency. Next is with C. Now we have to connect a capacitor across the resistance. So capacitor is here. It's positive terminal this one, negative terminal this one. And this wire will connect to the upper side and this one to the lower side. Then the capacitor is connected. So capacitor is connected between resistance. Okay, now you just follow which type of waveform is there. It is our with C waveform. Again we are follow. You just follow. It is without C. Capacitor is open. Capacitor is open. Now I am connecting. As you follow in CRO, it is with C. So with C it is more DC. The ripple is less, so it is more DC. Now we have to measure voltage, DC voltage with C and AC voltage with C. So DC voltage we are measuring. The multimeter is in DC level and our voltage should increase. It is 5.2 volt or it's 5.1 something, 5.1819 like this, okay? Or 5.2, better to say 5.2. 5.23 is the DC voltage, and what about AC? It will decrease. It will go down. And how much? It is 0.34. It's 0.34. Then the new ripple factor will be 0.34 divided by 5.2, and it will be near about 0.6. That all are the readings. So this is our complete data. You can copy in report sheet. And you also draw the waveforms. Whatever waveform you got, that is first it is sinusoidal waveform is the input signal. Then it is a full wave rectification. That is positive half cycle is here and negative half cycle also in positive half. So this will be drawn in graph sheet, and that is the output with C. Capacitor charge from here to the peak again is come here again go to this. So that is with C waveform. Whatever you seen in last. So that's all for this experiment.